In this video, let's re-examine functions. So we have basically three types. One-to-one function, which assigns a unique domain element for each range element. Onto function, where we have equal codomain and range. That is, all of the codomain were assigned to a particular domain. And finally, one-to-one correspondence or bijection, where it is both one-to-one and onto at the same time. So one-to-one function, as exemplified here, we have one unique domain element assigned for each range element. Say we have 1, which is assigned to C, and 3 we assigned it to D. 4, the domain was or is A, and 5 was assigned to B. So we could formally define this by logic for all X, for all Y, such that X, Y will be elements of the domain A, for example, to be specific. So if X is not equal to Y, so this should imply that your f of X is not equal to f of Y. A counterexample to this is, what if we have an additional element, say that element is E, and I also assign E to 5. So in that case, this will be already a counterexample, because in this case it is already assigned to B. So B is not equal to E. So in this case, this is true, and it will imply that their assignment should not be the same. So it should imply that f of B should not be equal to f of E. However, with the addition of E, they are both assigned to 5. Making this statement false, and hence truth implying falsehood will give us false. Thus the one-to-one definition no longer holds if you assign two domain elements to a particular range element. Another case, we have onto function, and as visible here, our domain or codomain, in this case the codomain, is equals to the range. And this can be formally defined as, for all Y, there exists an X. Again, let's clarify what Y is. Y will be now the element of set B of your codomain. So this is my set B, and this is my domain A. So for all Y in set B, there exists an X, which is an element of your domain, such that f of X is equals to y. So this is basically just the mapping. Y, here we are mapping the values of set A, the domain, to set B, and the quantification here is for all domain elements, say y here, there will be an existence of a particular domain element assignment. So codomain here will be equal to the range. So f of x will be equals to y. Finally, we have one-to-one correspondence or bijection. So in that case, all the codomain elements are assigned, and these assignments are unique, so making it both onto and one-to-one at the same time. So a question also arises if how many distinct functions can be defined from set A to set B. Say I have my domain here, set A, and codomain set B. How many functions can I create by mapping the elements of A to the elements of B? And the question basically will be answered by emphasizing the number of assignments per domain. Say I have n domain elements, so without loss of generality, let's say that I have n domain elements. So this first one, second, and so on up to n. So this will, let's name this as my domain A sub 1, for example, A sub 2 up to A sub n. So in the first domain element, how many possible assignments I could assign it? So that will be answered by the number of distinct elements of your B, because I will simply choose from my codomain. So this is the cardinality of B, or the number of elements, unique elements of your codomain. The same with A2. So remember that in a function I could repeat the assignment and so on up to n. Applying the product rule in counting principle, we could have the cardinality of B raised to n. But what is n? N basically is the number of elements or distinct elements of A. So n is basically equal to the cardinality of A. Therefore, for the how many distinct functions can be defined, this can be equal to just the cardinality of your B raised to the cardinality of your domain, which is A. And that's it. How about for how many one-to-one functions can be defined from set A to set B? So distinct functions can be defined from set A amounts to the cardinality of B raised to a, cardinality of a. And this is because we could repeat the assignment. However, for a one-to-one function, repetition is no longer allowed. So in this case, we will have unique elements. So we could repeat the visualization again. If there are n elements in the codomain or in the domain, so this is my a sub 1 domain element, a sub 2 up to a sub n without loss of generality. So we could have the cardinality of b here in the first element. In the second element, I already chosen one element of b, so I cannot repeat it. Therefore, this will be b minus 1, cardinality of b minus 1. And after that, cardinality of b minus 2, until this is when a sub n, this will be cardinality of b minus n plus 1, I think. So in this case, how can we solve the total? Again, by product rule. This will amount to just the permutation of b, or we could express this as b factorial divided by this is divided by b cardinality of b minus the cardinality of a, and quantity factorial. So this will be my answer. As you notice, if we examine the term at the denominator, this will become negative. So the denominator will be limited by a should be less than or equal to, so it could be 0, so b minus a could be 0, so less than or equal to b cardinality. Because if we think about it, if the cardinality of a is greater than the cardinality of b, then there will be more elements in the domain than the codomain. Thus, a one-to-one function will not exist. So, one-to-one function does not exist. Okay, so this equation is bounded by when a is less than or equal to your b, and that's it. For the next video, we're going to compute the onto functions and bijective functions.